Okay, so first problem we're going to look at is number 2, and this is like problems 1 and 3. So if we want to find two additional points from negative 2 pi to 2 pi, that means we want to add or subtract either 2 pi to negative 3 pi over 4. That would rotate the array from the origin, or the segment, originating from the origin to pi, which put it back in the same spot. So that's one way we can do that. The other way is adding or subtracting pi, and then that would make the radius negative, as we discussed in the lesson. So imagine if you're at, for instance, a 45-degree angle rotation with a radius of 2. If you rotated pi, which would put you at 5 pi over 4, in order to get that same point, you need to go in the opposite direction. So first thing I'm going to do, since it's negative 3 pi over 4, I am going to first add 2 pi, as I know that will definitely keep me in that range. So if I add 2 pi to it, and 2 pi with a denominator of 4 is 8 pi over 4. Quick way you could do that is putting 4 in the denominator and then saying, oh, I got to multiply that by 2, and that gives you 8 in the numerator. You get that gives us 5 pi over 4. So 5 pi over 4 is the same rotation as 3 pi over 4. Therefore, another point that is the same would be negative 1, 5 pi over 4. Another way would be adding pi to it, or subtracting pi. I'm going to just add pi. So if I add pi, I'm going to put a denominator of 4, and then I want the numerator to be the same to make a pi. So if I do that, that would end up giving us negative 3 pi over 4 plus 4 pi over 4 gives us 1 pi over 4. And then that changes our radius from negative to positive. So I change the negative 1 to a positive 1, and then my rotation theta would be pi over 4. So there's 2 more points that would give you the same coordinate as negative 1 comma negative 3 pi over 4. Okay, I'm going to do number 10 here, similar to 9, 11, and 9, 11, maybe another one. This is going from polar to, so I'm going to write it like this, polar to rectangular. And when we're going from polar to rectangular, we want to get x, and we get x by relating it to r and theta by r cosine theta, as we explored that. And then y we get by r sine theta. So all we're simply doing is plugging in r, which is 3 above, and then cosine 3 pi over 2. Cosine 3 pi over 2 is saying what is the x value of 3 pi over 2 rotation, which is 0. So we get a 0 here, because 0 times 3 is 0. Y, we have 3 times sine 3 pi over 2. And sine 3 pi over 2 is negative 1, so think about, that would look like this, 3 times negative 1, which then gives us negative 3. So that would be the coordinate in rectangular form, 0, negative 3. So you think about it, let's just check it. If I grab 0, negative 3, that would be going down 3. If I graph 3 comma 3 pi over 2, we rotate 3 pi over 2 and then go out 3. If you look, we get the same coordinate. Okay, 22 is similar to the problems from like 17 through 31. This is when you're in rectangular form and you're converting to polar. So polar, r, is the first part of the polar coordinate. The way we get r from x and y is root x squared plus y squared, because r is the hypotenuse of the right triangle. Gets us to a coordinate. Theta, we get, sorry if I have background noise, I'm down the hall from my daughter's class. Tan inverse of y over x, and we have to keep in mind with tan inverse, our tan inverse rules apply, and therefore it's going to be the reference angle either in the first or fourth quadrant. We have to keep in mind where our coordinate is 3, negative 1. So if we first want to find r, we're going to go root 3 squared plus 1 squared. Note, I can suppress the negative, because if I have negative 1 squared or positive 1 squared, both of them would turn positive. So if I have 3 squared plus 1 squared, that would give us root 10, 9 plus 1. And now theta, if I do tan inverse inverse of y, negative 1 over 3. That's going to give us a decimal, since that is not a unit circle rotation, or typical unit circle, 30, 45, 60. So we're going to go to our calculator and do that calculation and get a decimal. Note, if it's not a decimal, if it's a unit circle rotation like pi over 4, etc., then you use that. Follow it the same way as this. Okay, so tan inverse negative 1/3 gives us a theta of approximately negative 18. I'm just going to round it to the nearest degree. So it would be negative 18. So remember, tan inverse, we have the restrictions of first and fourth quadrant, and since it's a negative ratio, we're going down negative 18 degrees. So what I want to do is figure out what that is from 0 to 360. It's a little easier to work with then, so I just do 360 plus negative 18, which is the same as 18 minus 18. So that would give us 342 is our angle. So the polar coordinate would be root 10, comma, 342. Okay, next we're going to look at converting rectangular equations to polar. So from rectangular, we're going to go to polar. Very simple in terms of the substitution. You just plug in r cosine for x, so I have 3r cosine instead of 3x, and 5r sine. So now our goal is to solve for r. So I'm going to do two things. First thing I'm going to do is I'm going to move the 2 over. Now why did I do that? Well, if I look at those two terms, I'll go ahead and rewrite it. If I look at these two terms, our goal overall when we're solving for polar equations, it's preferable most of the time, not all the time, to have the r by itself. So what I did is I looked at those three terms and I said, oh, the 2 doesn't have an r in it, but the other two do. So if I get those two by itself, I then could GCF an r and then get the r by itself by dividing. So now that I have those two terms by itself, I'm now going to factor out the r. And that equals 2. Now looking at that kind of looks like a hot mess. Really isn't, though. If we look at like this right here, that's just a number. And it's a little different than what we're used to looking at with equations. But if you look, if that's just a number times r, how do you undo that number being multiplied by r? You divide by it. So we're going to divide by it, and we're just going to rewrite it. 2 divided by 3 cosine theta plus 5 sine theta, and that would be the form of it. We'll do one more problem on the next page. Okay, let's convert this xy equals 16 is number 41. I'm going to put a r cosine for the x, put that in parentheses, and then an r sine for the y equals 16. Again, we're going to try solving for r. I'm going to try getting it by itself first, so I'm going to put the r's together and make that r squared. Now we have cos theta times sine theta equals 16. And now we're just going to solve for r squared. Same thing with like rectangular equations. Typically we solve for y, but not all the time. Sometimes we solve for x squared plus y squared in the form of a circle. Same with polar, so we're still trying to get comfortable with polar forms. But typically if you have a r squared with an equation or just an r, you're going to solve for the r, you're going to solve for the r squared. We'll get used to those nuances as we move forward. So if we look there to get r squared by itself, we're going to divide by the cosine theta and the sine theta. And that will be your final answer right there. Okay, looking at this one, if we are converting from polar to rectangular, look at this and different things we talked about is we want like if we have a cosine in the problem, we want an r cosine. So that may suggest that we want to multiply both sides by r, but there's a problem because the cosine's in the denominator on the right-hand side over here. So if I put an r here, that's getting distributed in the numerator. It's not going to the cosine, so that's not really helping. If I multiply both sides by the 1 minus cosine, I take this and multiply it by both sides. Now I have an r times those two terms. And then I can distribute the r in, and I have something to work with. So that's what I'm going to do. I'm going to multiply the 1 minus cosine to both sides of the equation. That's what it'll look like on the left. On the right, note if I have 1 minus cosine here, these cancel, and I'm just left with 1. Okay, so now it looks like we're getting somewhere. I can distribute in the r, so I have an r minus r cosine theta. And what's nice here is r, we know what r is. That's going to be, in terms of x and y, that's going to be root x squared plus y squared. Just like r squared is equal to x squared plus y squared, r would equal the square root of it. Minus x equals 1. So now I have everything in terms of x and y, and now it would seem reasonable if we tried cleaning this up a bit. An easy way to clean that up would be getting rid of the square root. So what I'm going to do is I'm going to get the square root term by itself by adding over the x term. And then what we need to do is get rid of the square root by squaring both sides. Now that that term's by itself, we can square both sides. Left-hand side, the square and the square root are going to cancel, so I'm left with the x squared plus y squared. Over here, I'm going to FOIL that out, distribute it out, so I have x times x, which is x squared. Middle terms would be 2x, and then 1 times 1 is 1. And now I look at that and I go, okay, well, I got x squareds on both sides, so I can cancel those out. And now we have a y squared equal to 2x plus 1, and typically we're used to seeing like an x squared with a y rather than a y squared with an x. So we could just leave it right there. That's pretty close to like a polar form of a parabola, a sideways parabola, like a left-right facing one. You would want to factor out the 2 if we wanted in that form, but that's okay. You could also perhaps square rooted, so you have y equals root 2x plus 1 as your final answer.